This lesson is all about sets. We will define a set to be a collection of objects. For example, spring, summer, fall, and winter would be the set of seasons, and we could give that a name, and oftentimes we use capital letters for names of sets, so we might say that the set of seasons is called S. Each season, carrying this example through, would be an element of the set. And in general, each object in a set is called an element. So not only is spring an element, but summer is an element, fall is an element, and winter is an element. So this set has objects called elements. There's a standard notation for indicating the number of elements in the set. In this set, there are 4 elements, obviously. And so we write small n and in parentheses the set. So I would read that as the number of elements in set S is equal to 4. Let's look at some more examples. I might call the set T the numbers 1, 2, 3, 4, 5. Perfectly good set. I might call the set U the numbers 1, 2, 3. Now the dot, dot, dot just indicates that the pattern continues. So we're doing consecutive integers here, 1, 2, 3, 4, 5, all the way to 1,000. So the dot, dot, dot or the ellipsis means continuing the pattern. The set V might be the numbers 1, 2, 3, 4, and then again dot, dot, dot. That means it continues indefinitely. There's no last number, there's no endpoint. So that set just keeps going. This one's a little different. We're going to call the set W this set. Now, we need to talk a minute about what that means and how to read it and think about it. And this is called set builder notation. Sometimes the objects in their set are such that it's very time consuming or awkward to list them all, or even if there's a pattern or not. So there's also the possibility of just saying what the set is, and this is what set builder notation does. It just describes the set. I would read this as the set of all x. The colon is read as such that. So the set of all x such that, and then the description follows, such that x is a two-legged animal. So I would say W is the set of all x such that x is a two-legged animal. And all I'm saying here is that W is the set of all two-legged animals. That's called set builder notation. Now, a set is well defined, and that's a mathematical term, if it's possible to definitively determine whether or not any particular object is a member of the set. In other words, if you can for sure say that something is or isn't an element of a set, then that set is said to be well defined. For example, if the set A were the set of numbers 1, 2, 3, 4, 5, absolutely certain you can say if something is or isn't a member of that set. 6 is not, 5 is, 2 is, 87 is not. Perfectly well defined set. But if I say something like B is the set of all x such that x is tall, I'm saying B is a set of tall somethings. That's not well defined at all. First of all, who would agree on what's tall? If you're talking about a tall person, a tall tree, a tall building, and even if you knew that, what's the cutoff between being tall and not? That's sort of subjective. So that would be a set that is not well defined. Use a lot of symbols. This is the symbol for the phrase is an element of. So if we wanted to say that something is an element of a set, rather than writing out is an element of, we can use that symbol. So for instance, if I write the set A, which is the set of numbers 1, 2, 3, 4, 5, then I could say 2 is an element of A because 2 is an element of A. I'm just using the symbol in place of the phrase. in general, if we want to say something is not, we put a slash or a diagonal line through it. So, for instance, I could say 7 is not an element of the set A. And if you look up here, obviously 7 is not. So the slash is a sort of a general symbol for not whatever the original symbol stands for or stood for. It is possible for a set to have no elements. That set is called the empty set, or sometimes it's called the null set. For example, if I said M is the set of all X, such that X is a female U.S. president before 2010, there hasn't been a female U.S. president as of yet, so that set would be empty. Now we write empty sets. There are two common ways of writing them. You can write empty set as a circle with a slash through it, or you can write it as a set of braces with nothing in there. The beginning brace and the ending brace are the way you contain the elements of the set. So if there's nothing between the braces, that's the analogy is that it's an empty set. So either of those two notations, either is acceptable, and you'll see them both used. Now going in the other direction, the set of all elements under consideration for a particular problem is called the universal set, and we usually use capital U for that. For example, if you're choosing a 3-person committee from a 50-member club, the universal set consists of all the people in the club, all those 50 people. The universal set would be the 50 members. If, for instance, you were looking at course grades in a class where the only possible grades were A, B, C, D, F, and W, then the universal set would be the set containing those possibilities. If you roll a die twice and count how many 5s you get, well, think about it. If you roll a die twice, you could get no 5s. Even though you rolled it twice, you're not guaranteed a 5, so you could get 0 5s. If you rolled a die twice, you could get a 5 and then something that wasn't a 5, so you could get exactly 1 5. Or it's possible you rolled the die twice and you got a 5 both times. So the universal set there would be the possible number of 5s when you roll the die twice. You could get no 5s, you could get 1 5, or both of them could be 5s. That would be the universal set for that problem. The thing to remember is that the universal set is contextual. It depends completely, absolutely completely, on the context of the problem. If you're talking about a certain group and everything that you're choosing is going to come from that group is your universal set. If you change to a different scenario and doing something different, your universal set will change. For example, if you're showing the results of a coin flip, something very simple, heads or tails, that's your universal set. If you roll a single ordinary die and you're looking at what comes up on the face when you roll it, then the universal set is the set containing 1, 2, 3, 4, 5, and 6. Those are the only thing possible. There is no 7 or 50 on an ordinary die. Universal set is contextual, depending on your problem. Now, we talked about the number of elements in the set earlier, but technically that's called the cardinal number of the set. The number of elements we say sort of just informally, but that's actually known as the cardinal number of the set. So when I said the number of elements in set A and showed you the notation earlier, that's really the cardinal number of the set. Most people just say that it's the number of elements in the set. So technically we would say it's the cardinal number of A, but most people would just say it's the number of elements in the set, and everyone knows what they mean. And again, going back to some concrete examples, if I have the set A containing 1, 2, 4, 6, 8, 10, then I can count 1, 2, 3, 4, 5, 6. The number of elements in set A is 6. Now, a set does not have to be finite. A finite set is a set whose cardinal number is a whole number. A whole number is the set starting with 0 and going consecutively by 1. So 0, 1, 2, 3, 4, 5, 6, 7, however far you want to go. If the cardinal number of a set is one of those whole numbers, it's said to be finite. If it's not, that set is said to be infinite. For example, suppose we have the set A consisting of the elements 1, 2, and 4. That set is obviously finite because the cardinal number is 3. 3 is a whole number. If the cardinal number of a set is a whole number, then it's finite. On the other hand, the set A consisting of the elements 2, 4, 6, 8, which means it continues forever, there is no whole number that you can say is the cardinal number of that set. So that set is said to be infinite.